Good morning, ladies and gentlemen. This is Ben Keys with Applied Flow Technology. Hope that everyone is doing well and having a fine week. I just want to thank you all for attending the webinar here to take a look at the new features of AFT Impulse 7, and excited about a lot of stuff that we have going on. And so I'll go ahead and get started here in just a minute. Before that, I want to let everyone know that the webinar here is being recorded. And that way, if you're listening live, you'll be sent the recording. That way you could listen to it again later if you like. Or if you want to send it around to your colleagues, you can do that. And then after it's finished, it will be available on our webinar library. Speaking of our webinar library, if you are not sure where to find it, you can go to our website, aft.com, and under the Learning Center, go to Webinars and then Webinar Library. So when you go to the webinar library, then you can fill out this form of your information. And then when you get into the webinar library, this is where you can find several previously recorded webinars that we did on Fathom, Arrow, and Impulse. And there's a lot of really good content there to learn a lot more about how to use the software effectively and efficiently. So be sure to go through and check out those webinars. Also, we'll be doing more upcoming webinars, and so you can always register for those on our upcoming webinars page. Stay tuned. We're about to start posting some more webinars here in the next few months. And then another area that I want to point your attention to is our tips and tricks page. Our tips and tricks page contains several hundreds of blog articles on how to use the software more efficiently and effectively. And you can find all of those blogs here on our website. Lots of good information there. And so we'll go ahead and jump into the content for what I'll be talking about today. So let me move my web page out of the way and we'll jump in here. And so where do you find AFT Impulse 7? First off, you need to log in. If you don't already have a login to our website, you can easily create one. Anyone can create a registration on our web page, and that way you can get in there and download the latest release of the software. And also you can view the release notes, which will tell you various changes that we make during the life cycle of a new version. In addition to that, if you go to products and then AFT Impulse, you can find our full features list. And on the full features page, you can find all of the full new features of AFT Impulse right down below. The other way that you could figure out what the new features are, and really the best place to go, would be in the AFT Impulse help file itself. And so if you went into AFT Impulse 7 and then go to the help menu and contents and index, this is where you can find all of the new features information. So it's under the getting started section and then new in version 7. And this will walk you through all the new features that were added in Impulse 7, as well as Impulse 6, Impulse 5, etc. And not only will it show you what the new features are, you can also go to the respective topics for those features and learn about how you would actually implement and use those types of capabilities. Right now, we have a very special promotion going on where if you are a Fathom user and you already have the Fathom software, you can get 10% off of AFT Impulse, and that promotion goes on till March 31st, 2019. This is where you can find the webpage that talks about those details, and so we highly recommend that you take advantage of it because things never stay in steady state. And waterhammer is something that goes on all the time, and it is critical that you account for waterhammer and evaluate it carefully because there can be disastrous impacts on your system if you don't. So this is where you can find out about that special that we have going on. Now what I want to do today is I want to focus on the key new features of AFT Impulse 7. I'm not going over every single new feature. So again, if you go into the help menu for AFT Impulse and open up the help file, that contains all of the new features. In addition to that, if you go to our website and then under products and go to AFT Impulse, when you scroll down on this page to the list of full features, here's where you can find the full new feature list. And so this is conclusive here that you can download and print it out if you want. And so that's all the new capabilities that we have built in. I'm going to talk about these ones today. So one of the most powerful new capabilities of our software is the ability to import neutral files. That way, they will build the model of your piping system for you. And we can import neutral files in several different formats. Piping component files, Caesar2 neutral files, EPA-net. We can also import GIS shape files. GIS is not new in version 7. It came out in Impulse 6, but it has been enhanced for a lot more streamlined usage in Impulse 7. So those are the new formats that you can import to build your model and save a lot of time. I'll show you how to use those capabilities here today. Also going to talk about Excel integration. For the longest time, Impulse has had the ability to import changes to a model from an Excel spreadsheet. That way you can instantly update massive amounts of data. But we have refined and dramatically improved those capabilities with our new Excel import template that you can start from. So you'll see the advantages there. In addition, instead of just updating one scenario at a time, there's a way you can import changes to multiple scenarios all at once. So that's another major time saver. So that's coming into the software from Excel. We also can go from the software out to Excel with the new Excel Export Manager, and this is a really powerful way of being able to add any type of parameter that you would like to Excel or that you would like to export to an Excel spreadsheet to do additional calculations or additional graphs is very powerful. And so I'll show you what that looks like today. A few other Impulse specific new features that I'll be going over. Well, the isometric grid is also a new feature that's in Fathom, Arrow, and Impulse for the latest versions. But some of the key Impulse ones are multi-event transients. There's the new pump property window that's been completely redesigned, visual report animation. So we'll see all of those things today. So let me go ahead and get started, and I'm going to talk about model importing first. So let me minimize my PDF here, and I'm going to jump into Impulse now. So this is AFT Impulse 7, and in order to import a neutral file, you would go to the File menu and then go to the option to import the piping layout. And these are the 4 different types of neutral files that you could import. Again, piping component files, Caesar2 neutral files, GIS, and EPA-net. Now let's do the piping component file. That's the one of the more generic ones. The piping component file is typically going to be created whenever you save an isometric drawing from Plant 3D or AutoCAD or CADWorks. Various different drawing tools that can create an isometric drawing will usually automatically save a PCF file that contains all of your piping information in a text file through a various isogen format. And so you can import that text file and our software can read it and it will build the model of your system. So when you select which type of file format that you want to import, it modifies the quick access panel here so that you can control which type of information gets imported. So what I'm going to do is I'm going to click on this button right here, and you would browse to the folder on your computer where your neutral files are saved. So I've got my Impulse 7 new features webinar, and then the webinar models and model importing. Okay, so here's my two piping component files. I have PCF number 1 and PCF number 2. So if I click on PCF number 1, then I can move this preview mode around on the workspace however I want. I can zoom in and out so I can place it in different areas. And then Impulse is going to read what the PCF object is, and it's going to translate it to an AFT object. For example, a valve would become a valve, a area or a reducer would become an area change, things like that. And so this gives you a lot of flexibility over how you import the model in, because let's say, for example, that this valve right here is actually supposed to be a different kind of a valve. Maybe it's supposed to be a relief valve. What you can do is click on this drop-down menu for the AFT object side, and then you can specify whichever type of junction that you actually want to import it as. So when I chose relief valve, it changed the valve to the relief valve, which I'm not seeing where it is. Maybe it's hidden somewhere. So that's how you can specify what types of valves. Oh, it looks like it changed it to something different than it shouldn't have. But anyway, that's how you can control what gets imported. If you click on this button right here for property window, this contains text information from the PCF file for that object. That is information that we actually need for the waterhammer model in Impulse. Now, if you go down lower and you click on the box to show advanced properties, this is all of the information that gets brought in from the PCF file into your model. We don't care about any of that information for the waterhammer analysis. It doesn't matter. But if you still want to contain that information within your model anyway, what you can do is, if you scroll down right here in the bottom area, let me highlight that, in this section, you can check the box for this option right here to import that data to the notes fields. So if I check this box right here, it's going to import all of this text information into the notes field for my pipe and junction property windows. A few other things: we will prepare a automated scaling on the model for you. You can adjust that manually if you want. You can show your junctions, combine pipes. So let me turn this off. If I turn this off here, that's not going to combine pipes. It's going to do individual short segments. And also, I might not want to import my elbows as pipes. So if I uncheck that box right there, what you'll see is branch junctions throughout the model that simulate elbow junctions. Now, AFT Impulse does not have elbow junctions in the software. Fathom and Arrow do, but Impulse does not. So that's why if you look at the objects here, you'll see how elbows will get translated into branch junctions. And they would, by default, be branch junctions with no K-factors on them. Now, the reason why we do this in Impulse is because the name of the game in Impulse is to simplify your model as much as you can. And you can do that and still maintain a very high level of accuracy to get really good results. And the issue is, if you are including every single elbow like how I'm doing right here with the branch junctions, then this is going to include several short pipes throughout your model, and that's going to drastically increase your runtime. And it's just completely unnecessary. You don't want to do that. So the best practice in Impulse is, instead of modeling your elbows explicitly as junctions, the best way to do this is to import them as part of the pipes themselves. So that way you can import them. Now, when you do that, it has these all as separate pipe segments. What you would then do is check this box right here to combine the pipes when possible. That way, it wouldn't have a whole bunch of short pipe segments. It would just create one segment, and it would contain everything within it. And so that's a good practice for AFT Impulse with doing waterhammer modeling. I'm not going to go into a lot more detail about the waterhammer modeling aspect of things, but I want to point out a couple of things. If you go to our Learning Center under video tutorials, this is where you can find some video tutorials that we've done. And for Impulse, there are some really important ones that you should watch. So if you filter this down by doing Impulse and then Technical, you will find that there are several video tutorials for Impulse that are imperative. This one is one of the most important, pipe sectioning. This will show you effectively how to section the pipes in your model to avoid unnecessarily long run times. That way, you're not including all those short segments of pipe because they're just not needed. There are also some other transient videos there that are really useful. If you watch one of the previously recorded webinars on AFT Impulse that we did last year, then in here you can watch one of the webinars that I've done previously, which is a introduction to AFT Impulse right here, and that'll give you a few more details on sectioning, because I do go into it a little bit in that webinar. So be sure to watch that and you get an idea of what I'm talking about with the sectioning. So here, it's best to import your junctions into the pipes themselves as much as you can. So when I finish setting all this up here, I click on the import button, and this will build the model of my piping system for me. And it doesn't take very long at all, even for really large models. Now here's a really useful advantage is after I do one, I can select another file and I can import this as well. So you are not limited to only importing one PCF file at a time. You can do multiple PCF files. So now when I import him, it'll get built on the same workspace. If it's a completely separate model and a completely separate system, that's fine. But you could also connect this system with the first system that was originally built up here. So maybe it might be the case where this pipe is going to be deleted, and I would actually want to select this pipe here and connect it in that fashion. So now the two systems are interconnected with each other, and that's how you can import the model. If you look in the model data window, you'll see what type of information gets brought in. We are reading in the length of the pipes, as well as the hydraulic diameters and the elevation data for all your junctions. So that contains a lot of good information that will save you tons of time without having to build your models from scratch. So if you have those isometric drawings, be sure to take advantage of using that capability. Again, you go to File, Import Piping Layout, pick the one that you want to import, and then it'll build the system for you. Next thing I want to talk about is Excel integration. And let's talk about the case of importing changes to Excel first. So let me open up another model here really quick. Give me just one moment. There it is. So I need that file, and then also there's a couple other files, and I want my workbook, scenario names. Okay, so first things first is let me show you where you can find the Excel template that we have prepared for you. So if you go on your computer and you browse to where Impulse is installed, which is typically on your C drive under AFT products and then AFT Impulse 7, this Excel file right here is the workbook template that we have provided for you. Now, something I want to recommend is do not open this file from this path. That's a very bad thing, because if you open up that file, you're going to potentially make changes to it, and that's going to change the file from the structure that we've built for you as a template. So you don't want to do that. Instead, what I highly recommend is to select the file and copy it. Then you can go to your desktop or somewhere else on your computer and paste it. And once you've pasted it, open it from that new location. So I'm opening up the workbook template, and this is the template that we've provided for you. Now, previous versions of Excel, or I'm sorry, not Excel, previous versions of Impulse allowed you to import changes from an Excel spreadsheet. But what you would have to do is you would have to create the spreadsheet on your own. So you would also have to refer to the help file to figure out how to build the spreadsheet. Then you'd have to refer to the help file to figure out what the change codes were. So now in our new workbook, we've provided a template for you. There are some instructions right here which are really important to pay attention to, so make sure you read those. And then in the template, instead of having to figure out what the code numbers are for these different parameters that you want to change, you'd be able to just select them directly from the drop-down menus. So let's say that I want to add another row on here. So I would choose to apply it, potentially. And then let's say I want to change a control valve in my model. And the control valve in the model would have a certain junction ID number. So maybe that's junction number 53, perhaps. As you can see, it highlights necessary information that you need to specify. So the next thing I'm going to do is choose the parameter that I'm going to change. I might want to change the control setting. Now, you can make your changes in different ways. You can either set it to a value exactly. So let's say I want to set my set point to 500 gallons per minute. That's where you would do set equal to value, and it'll change it to exactly that specification. There's another way, though, where maybe you want to change your control valves by a certain amount. So maybe you want to change all of your control valves and increase all of their set points by 5 gallons per minute. Then that's what change by value is. And then there's change by percentage, where instead of doing a value directly, you can change all of your control valves by 10%, and that's how they will apply the changes in the model. Now, the other new thing is this column right here, this scenario path. Before, when you were doing any Excel changes, you would have to make the changes to each scenario one at a time. So you would have to specify your changes in the spreadsheet and then go into your model and update your changes. They come back to your spreadsheet and modify them. For example, each different scenario that you want to modify. Now you can specify exactly which changes apply to which specific scenarios. So let me illustrate how this is done with an example now. So I'm going to close the original template. So here's my model file. I brought this model in from Fathom, and this is our hot water system. So if you went into AFT Fathom and you go to the help menu and then show examples, this is where you can find all of the walkthrough tutorials for the software. So in Fathom, there was a hot water system example. So I basically stole that model from Fathom, and then I modified it here for Impulse. So here are the three families of cases that I'm modeling. I have a whole family tree of different scenarios. So I have on here 3 different families. This family of scenario, I'm controlling the flow through the system by changing the pump speed in each of the pumps. So I'm not going to be using the control valves in those scenarios right there. I've basically ignored them. So that's the first family, is by changing the pump speed directly for a VSD. The second family of scenarios right here is, instead of you specifying the speed directly on the pumps, maybe I don't know the speed, but I know that all my pumps need to operate at 400 gallons per minute. That's where you can do a controlled pump set point. Impulse will then change the pump speed via the affinity laws to be able to meet your set point, and that's how you'll get your results. Finally, my last family of scenarios right here runs all of my pumps at 100% speed, and I'm going to control the flow through the system with my control valves. And this is actually the worst case scenario with control valves, because it's going to cause your pumps to operate really far away from the best efficiency point. They're going to be unreliable. They can have operational problems, and they'll wear out a lot faster, and then it'll waste a lot of energy costs as well. So if you wanted to, in Fathom, you can actually calculate what your energy costs are for each of these scenarios. That way you can see how much energy you save by using variable speed drives instead of control valves. Now that's a story for another day. So what I did was I built my model on the base scenario level right here. So I laid out all my pipes and junctions. After that, I did not define any input for my pipes and junctions yet. The reason for it is because I'm going to import those changes from Excel. So the next step that I did was I started creating my family trees of scenarios. So I started with my first family right here, where this is an identical copy of my base scenario, and then I created 3 children. The reason why I did that is so that I can keep things consistent, and I would only need to do a really quick global edit to each of these scenarios to change the pump speed. Now, when you create this initial child right here from the base scenario, you actually don't need to make any changes. I didn't have to do that because all my pumps were originally at 100% speed in the base scenario, and it stays that way through this whole entire family. So I didn't have to make any changes there. But the reason why I did this is so that I could select this parent scenario right here, and I wanted to right-click and choose Clone with Children. So if I go in here and I right-click the scenario, I can say Clone with Children. When you clone it, it then created this family scenarios, and all I did was go in here and I just renamed each of these scenarios. Now here's why I did the cloning operation, is because before I import my changes from Excel, what I had to do was I needed to go in here and load this parent scenario, and I selected each of these 3 pumps, and I did a quick global junction edit, and I changed each of those pumps to use a variable speed, which was actually control set point. So I set them all to 500 gallons per minute. The reason why I had to do this is because you have to set up a placeholder for changes to be applied in those scenarios. If I would have just left this blank and didn't type anything in, the Excel changes would not be able to work. The thing about the Excel changes is you have to have a value in a field existent before you can change it. So you have to just specify a placeholder there. Doesn't matter what it is. That's why I went into this parent scenario right here. I made the change once, and once I made that change in this fashion by going in here and typing 500 gallons per minute, and I checked this box to apply that change, what it did was it changed all of these 3 pumps to that type of VSD, and it also changes them in these scenarios as well. So I only needed to make that change once. Makes things really, really efficient. Then the last thing I did was I cloned this family of scenarios one more time, and I then had my 100% speed scenario. Actually, I did not clone, let me erase this. I did not clone this family of scenarios. I cloned this family of scenarios to generate this new family here. The reason why is because this family of scenarios is based upon 100% speed pumps before I make these changes individually. So therefore, when I clone them, all the pumps in these scenarios here will be exactly at 100% speed. So that way it minimizes the amount of effort that I have to do. So in these scenarios, I went in and instead of having the control valves be set to fully open, no control, what I did was I turned that off, and that way they can now control their set points. So after I set all that up, what you would do is go to the base scenario here. Same idea. If I look at my model data, all of my information for pipe length and diameter is blank. So you can't import to blank fields. You have to put values there. They just need to be placeholders. So when you do that, it also sets the units that you want to work with. So what I would do here is I would go to Edit and then Global Pipe Edit. And what I'm going to do is I'm going to set all my pipes to a default material. So I'll use steel, and then size, which would be 4-inch, and then standard schedule 40. I'll make them all 1 foot long. So when I do this global edit, it makes all these changes in this fashion. So now I have default length values, units, sizes, units for my sizes, and default materials and nominal values as well. Now I'm ready to import from Excel. So here, what I did was my first things I'm going to import are changes to pipes. So I have all of these pipe information that I'm going to make changes to. Nominal size, schedule, and pipe length right here. And so those changes are going to apply to the base scenario. When I apply these to the base scenario, it's going to change them all for the whole entire family tree. So again, you only need to make that change once. Next, I've got my individual operation scenarios. So I've got my pump speed scenarios, and then I have my control pump set point scenarios, and then my control valve scenarios. And as you can see here, I have my scenario file path name telling Excel which scenario to apply these changes to. Now, how do you easily get this scenario file path or the scenario path into Excel? If you go into Impulse, you can right-click on any scenario and say copy scenario path name. Then you can just paste it right in. However, there's an easier way. If you've got 100 scenarios that you want to be able to access really quickly without having to copy and paste over and over again, simply right-click anywhere in the scenario tree and then instead choose Save Scenario Names to File. And you can choose either of these options. And what that will give you is a simple text file that looks like this. So here I have all my scenario names. What I then did was I copied the scenario names from my text file. You could paste them into a separate tab on your Excel spreadsheet if you want. So I can paste them all in right here if I like. Or you could just go in and paste them into each individual scenario, and then you can copy and paste things accordingly. So it makes it really super quick and easy. So now I have 99 changes that I want to import into my model in 9 different scenarios. So I've got 99 changes, 9 scenarios that I want to make changes to. So here's how you import those changes. Go to File, and then you go to Import Excel Change Data. Choose your spreadsheet that you're going to import from, and then let it do its work. Now, if you look at what's going on in the bottom left-hand corner here, you can see how it is applying changes to different scenarios. So that's an indicator that Impulse is actually doing something for you. So when you do stuff like this, it could take a little bit of time. So just pay attention to what that's telling you. It is actually doing stuff. So here, this tells me all my 99 changes that were made. So that's good. So if I load my base scenario, I should see all my pipe lengths, my sizes. You can see how I've got both 6-inch and 4 inches, so that's good. If I load any of these individual scenarios, you should see the same piping information that propagated from the base scenario, which you do. And then if I right click, you can see 90%. You can see 90%. If I load this scenario here, I've got 85%, 85%. If I load one of these scenarios, you should see 400 gallons per minute. So there's 400 GPM, 400 GPM, and then in this family of scenarios, I would see 100% speed. So if I open up these pumps here, you can see that variable speed is set to 100% for each of these. And then if I right click, you can see you've got 1250 for each of the control valves, and then we should have 1,000 and 1,000. So there's 1,000 there and 1,000 there. So that's how you can import all of your changes to multiple scenarios all at the same time. Saves you tons of work. So make sure that you get familiar with how to use the Excel change data feature. It's a really useful tool. If you go to the tips and tricks page on our website, we have one blog article that was recently done. It's written by Raphael here. Now it's super easy. So this talks about the new format. Now this also references another blog. This was the old way of doing it. So if you read this blog back from October 2016, as you can see here, this is where you would have to get these change codes. So when you go into Excel, these are all the parameter numbers. So we did actually make it a lot easier for you. So that's importing Excel changes. The next thing I want to do is show you going from Impulse to Excel with the Excel Export Manager. So let me close out of this scenario here. Let me close this model file. I'm going to close out of this, and I'm going to open up another instance here. Let's see, close out of that. Go to my different folder here. Move that aside for a little bit later, and then let Impulse open up. So what you can do is in Impulse, there's a new feature called the Excel Export Manager, and it is where you can specify which different pieces of output you want to set into a spreadsheet for any sort of post-processing that you might care about doing. So let me browse to a file that I've already made. All right, so this is opening up my scenario tree. Okay, perfect. So this is not a new model file that I built on my own. It comes from, if you go to the help menu and then show examples and pick your favorite units, it is called the pump startup with event transients. So this tutorial will teach you how to build this model from scratch. It'll show you how to set up the various scenarios that you're supposed to run. So there's three scenarios. You have a situation where two of your pumps start up at the same time. The second scenario is where one pump starts, the other stays off. And then the third scenario is where one pump starts while the other one was already operating in steady state. So those are the three scenarios that this example has you build and work through. I made a couple of slight modifications for my Excel exporting. In the tutorial, it has you do a very basic transient where you set the valves immediately downstream of the pumps to open based upon a time transient. What I did was I made it a little bit more exciting. I set a single event transient instead, because rather than just opening the valves from the very beginning, I wanted to be a little bit more advanced. So here I am opening up these valves within 2 seconds, but this is only going to be triggered once my pump speed gets to be greater than or equal to 25% speed. So they're not going to start opening until my pump is a quarter of the way up to speed in its startup process. So that's just an example of some really sophisticated types of transient modeling that you can do. All right, so what I did here was I ran my base scenario, and let me run it here just to show you what's going on. If I go to my output window, I have pre-configured to simply show the maximum and minimum pressures, the maximum and minimum flow rates, and that's it. What I also did was I set up a transient force set between this location and this location, and then I did a second force set from this location to the tank. So the way that I set that up was by going to the analysis and then transient control, and I set up my two forces right here, as you can see in this window. And that way, when the pressure transients pass throughout the system, I can also calculate what the transient forces are on the piping. That way you can then export your transient force calculations into Caesar or Triflex or ROAR, and you can do a pipe stress analysis. So when I do the transient force calculations, this forces tab I have configured to show me what the maximum absolute pressure is. So I've got the maximum absolute pressure and the time in which it occurs. However, if I go to the graph results window, I pre-configured a few graph list items. So the graph list manager is a really powerful tool that allows you to create as many different graphs as you want. It's a filing system for all your common graphs that you'll commonly create. It saves you from constantly having to reset these parameters every single time that you change something. So instead, just set up your parameters and you create your graph once. Then, after you create your graph, click on this button right here. That will add the graph to your graph list manager. You can create as many folders as you want, and you can put as many graph list items in each folder. So here I have 3 items. I have one graph that I did, which here is containing the inlet and outlet pressure as well as the flow rate through the pump. So I've got my pump suction and discharge pressure for each pump as well as the flow rate. So that's where you see a lot of graph data here. Another graph that I did was the maximum pressure profiles. So I created 2 flow paths. One flow path is, if I do my groups, it's from the supply reservoir to tank 1. The other flow path is from the supply reservoir to tank 2, just like that. So this graph right here tells me my maximum pressures in that flow path and my maximum velocities. And last but not least, I have my forces. So for the forces tab, I'm plotting the forces for both of those force sets right here. And you can see how the forces change throughout the system. And this is going to come into play for my graph or for my Excel export manager. So once I got all of that stuff configured, I went into the Excel export manager, which is this new button right here. Let me circle it for you. It's that guy. And so the Excel Export Manager is where you set up which pieces of output you want to export. So I'll click on Open, and this will open up my Excel Export Manager. So I'm exporting 6 pieces of data right here. One thing that I am exporting is the transient max min table. So however I configure that transient max min in the output window here, that is going to be exported into my Excel spreadsheet, which has a default name of sheet 1. If you change the name in this cell right here, that's how you can create multiple tabs. So if you want to put different output results into different tabs, then that's how you can do that. So what I did was I specified cell A1, which is this cell right here, to start putting my data, and then it will calculate the ending cell. So if I want to export the transient max min table, just like how I've shown it in the output window, it's going to take up this entire section of area in the Excel spreadsheet. The next thing that I have chosen to export is my column of forces in the output window as well. And so as you can see here, I'm doing a column of data and it's forces, and I'm only doing 2 parameters, the maximum positive force and the maximum negative force. So that's the only thing that will export. And then finally, I'm exporting my 3 graph list items. So for the export type here, I would choose graph from the drop-down menu. There's a lot of flexibility of different options you can choose. I did my transient pipe. That's my suction and discharge pressure and flow rates at the pumps. And then I have my profile plot, which is my maximum pressure and velocity profiles. And then finally, I have my forces graph. And what I did was I added 1 row at a time, exported the data because I needed to figure out when you do a graph like this, it's not going to calculate the ending cell. It says it's the same one. So if you look down below here in the list, it's putting the starting cell for each of those graphs here, here, and here. The reason why is because we're not able to calculate an actual ending cell. This ending cell depends on how many data points you have. Maybe there's some data points that are not getting saved or perhaps stripped out, etc. So what I would recommend is if you are exporting graphs in Excel like this, or from Impulse to Excel, which you'll probably do fairly often, which will allow you to do multi-scenario graphing, I would recommend add 1 row of graphs at a time. So add this row, tell it a starting cell right here, then run your model and export your data. That way you can see where it starts and which column it ends in. So here I found that my first graph data, once it was all exported, it ended in like column K or L. That's where for my next graph right here for row 5, I told it to start in cell M23, which is right here. So on and so forth. So now that I have set things up for my exporting, what you can do is if you have multiple scenarios, you can actually do a batch run, which I've done here. I've told these 3 scenarios to run. I don't care about the base scenario. I only care about the 3 children. And I want to check the boxes right here to save my results with the Excel Export Manager. And what this is going to do is it's going to send the results of each specific scenario into a separate tab in the same spreadsheet. Now, because this does take a little bit of time, if I was to go through and run this and do the Excel export, it doesn't take terribly long, just maybe 1.5 to 2 minutes or so. So I'm not going to take that time to do it. I already have results for each of these scenarios, and I've already done my data dump. So that's my spreadsheet right here. So when you first export things, it's going to create this export guide tab. And this will tell you what was exported. It gives you information about the model, and it'll basically tell you if it was successful or not. So this makes it easy to troubleshoot things if things are not getting exported properly. So then I have all my results in my 2-pump scenario, my 1-pump scenario, and then my 1 pump with 1 already running scenario. So you can see all my maximum and minimum results here. And then I have my maximum positive forces right there, my maximum negative forces right there. And then here's all my graph data. So here's my first set of graphless items. I've got my suction and discharge pressures, and then I have my suction and discharge flow rates. Now, the reason why we can't calculate the ending cell is because we don't know how far down this goes. Here, I'm only saving results for every 10 time steps. So here it ends in cell 254, but you could have tens of thousands of data points. And if you have tens of thousands of data points, it might be hard to figure out where it's actually ending. So that's why you would need to do this approach first to figure out where it ends. So now if I scroll back up to the top here, I go over a little bit further, here's my profile plots. And then finally, if I scroll all the way over, here's my force graphs that I want to export. After that, you can do any type of post-processing in Excel that you'd want. We do have a blog article on our website on using the Excel Export Manager. So if you go to our tips and tricks area, it's, where is it? Maybe it's on page 2. There's a lot of pages. Here it is. So if you want to learn how to use the Excel Export Manager effectively, this is an awesome blog that talks about how to do it. It is written in terms of Fathom 10, but the functionality and the process is exactly the same in Impulse. All right. Couple other things that I want to show you here that are some of the key new features. Let me go ahead and move this out of the way, and I'll close my Excel spreadsheet. I'm going to open up another model. Pump trip with backflow. That's the one I'm going to do. Okay, so one of the things that we did in Impulse is we have completely changed the pump property window. So if I open up my pump property window, we have done a couple of things where we have made it a lot more clear on how to model centrifugal versus positive displacement pumps. So what you would do is you would choose either of those options, centrifugal, and here you would enter your pump curve data just like you would before. If you want to model a positive displacement pump, then you can do a PD pump, and you can change the flow rate in various ways. One way is you can just, the most simplest is just to do a constant flow rate. But that's not how a PD pump works in a waterhammer sense. For waterhammer, you can capture the true essence. So if you choose periodic, what you can do is specify your average flow rate, the number of heads on your pump that you have, and an operating speed, and that will calculate the cyclic behavior for you. So let's say my average flow rate is 200 gallons per minute, and I have 3 heads, and my operating speed is 500, let's call it. There's my cyclic behavior for how my pump is going to operate. So that's the periodic simple option. If you do periodic detailed, there's a little bit more information that you can specify. You can put what your bore value is, your stroke length, and your rod length, and that way you can be a little bit more sophisticated. So those are some more advanced ways that you can model positive displacement pumps and capture their true cyclic behavior in Impulse. Let's go back to centrifugal pump. We have simplified this so that you can have an easier way to figure out how your pump is going to operate when you have different types of situations. So one situation is if you never have reverse flow. If you never have any reverse flow, then what it would do is it would put essentially a check valve on your pump for you. And let's see, I'm not sure why it's not showing that. Let me open up this one. Oh, I know why. Okay, let me cancel that. All right, so if I was to choose never for the possibility of reverse flow and said that would never happen, then I can click on the animation play button, and this is going to show you how your pump is going to operate. It's always going to be forward flow and positive speed for your pump. However, if it's possible for my pump to have reverse flow through it, then I have a couple of boxes I can check right here. So if I uncheck prevent reverse rotation, you can see that you might have positive flow, positive speed, but you can also have negative flow and the pump could be spinning backwards. So that's a little animation. Now let's say that I want to put reverse rotation. I can check this box. That way, even if I get reverse flow, which is the orange lines, my pump can still spin forward, or it'll just stop. The other option is you can put a check valve on your pump. So if you have a check valve, then you can see how you would always be getting forward flow and it wouldn't be reversing. So those are some new animations that we've used to help clear up how you would model your pump. And then if you go to the transient tab, we have changed how we list out the transient options. You can either do a just change the speed versus time directly. So here you just have a VSD and you know how your speed changes. Or you can do inertial models. So you can do a startup with inertia or a trip with inertia. And so this makes it a little bit easier to figure out what you're wanting to do. So let me open up one of these pumps here. In this system, it's possible for my pumps to experience reverse flow and they can spin backwards. So that's why in this example, we have chosen possible for the reverse flow option. If it's possible you can have reverse flow, you're going to need to use what's called a 4-quadrant curve in order to get some level of accurate prediction for your pump head when it's spinning backwards or if it has reverse flow. So what you can do in that fashion is click on Specify Model. And this contains a lot of good detail, and it really clears a lot of things up on how you can find a 4-quadrant curve set that would match the specific speed of your pump. That way you can find a 4-quadrant curve to simulate how your pump would function when you have reverse flow or reverse speed. So this helps you go through the process of selecting a 4-quadrant curve a lot more intelligently. It does have a lot of information that you're going to have to read here, but this is critical because waterhammer modeling is not simple like it is for steady state. It's very much a black art and it can be really complicated at times. And so there are some important assumptions and things to pay attention to. And so reading this information, reading the little tip windows where you see the question marks, that's really key information that you need to not ignore. So don't just set this up and go. Make sure you read and understand what this information is telling you. And so all that is captured right here in the pump window itself. So that's the new pump property window. Last thing I want to show is the visual report animation. So if I go to open up another model, give me one sec here. There it is. We have a new way that you can visualize how your pressures and flow rates and velocities and whatever parameters you want to see are changing throughout your system. So here we have a very simple network, and we are doing a fast valve closure. And obviously one way, or the best way that you would analyze your results is to do graphs. So if I select this flow path here and go to my graph results window, I'd have to run it first. The best way to review your results is through doing animations. So I've selected those pipes in the workspace, and I want to animate how my pressures change in that flow path over time. So this shows you how things change over the flow path, and it gives you a lot of really good information. So this is one of the best ways to analyze your results, to be able to see what's going on. But there's a new way. If you go to the Visual Report tab here, the Visual Report is what allows you to overlay your input or your output data right on top of the model itself. And so the new capability here is this animate option. And so if I go in here and I choose animate like I've done, I can specify which parameter I want to animate. So right now I'm going to animate pressure. And I've already modified how I want this to be shown. So the lines here that you see in each of the pipes represents the different sections in the piping. So I've displayed where my pipes are sectioned. And what this will do is when I start to play the animation, you're going to see how the colors will change as the time changes during the transient that I'm doing. So I'm doing a valve closure right here, and you're going to be able to see how pressure waves interfere with each other during this activity. So I'll move this to right here, and I'll play it. So my valve takes about 2 seconds to close. Maybe it's only 1 second. And you can see how the colors are starting to change. And they're very dark red for higher pressures, but the valve is not fully closed yet until right now. So now the valve is fully closed, and now you can see how the pressure waves are passing throughout your network based upon colors. And so this makes it a lot easier to be able to see how your pressures or your flow rates or velocities are interfering with each other throughout your system. And so that's the Visual Report animation capability. Really powerful, really useful. You don't have to display these sections like this. You could uncheck that box and smooth colors between the pipes. You also don't have to use your junctions. You can choose to hide those, and that way things get smoothed out a little bit more nicely. All right, so those are the key features that I wanted to go over today. Again, I did not show you every new feature that's in Impulse. There's a lot more new features that I did not go over that really enhance the capability. So if you want to see what those new features are, you can either open Impulse 7 directly, and then under Getting Started, go to New in version 7, and this is where you can see all the new features here. And then you can also find the information from our website. So if you go to our website, again, AFT.com, under Products, go to Impulse. And then once you're on the Impulse page, scroll down a little bit to view the list of full features. Then here's where you can find the full Impulse 7 new features list, and you can read about that in a little bit more detail. Last but not least, on our main homepage, if you want to get more information about that special, right here, AFT Fathom customers can save 10% on Impulse. In addition, that also means that if you don't have Fathom yet, but if you buy Fathom and Impulse together, then you'd be able to get 10% off the whole order in that case. So this gives you the details. If you have any questions, please let us know. You can feel free to contact us at sales@aft.com. So if you go to contact, this is where you can find all of our contact information. You can give us a call. If you have technical support related questions, don't send those to sales. If you have tech support questions, go to our support center instead, and then fill out a support ticket, and our support team will be able to help you out. Thank you all very much for your time today. I really appreciate it. And if you have any other questions on Impulse 7, let us know. We'll be glad to help you. And we will see you in the next webinar. Have a wonderful day, everybody.